The AV-HSI is the latest accessory for the Avionics AV30, and it allows the AV30 to be the primary navigation indicator for IFR flying. It interfaces with GPS and VHF navigators to provide en route and approach guidance, including ILS approaches and GPS approaches down to LPV minimums. We demonstrated the prototype at Oshkosh last year, and over the last several months been having a lot of fun refining and flight testing the product. It's available now for experimental aircraft, and will be going through the FAA certification process shortly. In my IFR flying, popping out of the top of an overcast and seeing the sun for the first time in days hasn't lost its magic, nor has coming in on an approach and finding yourself right on center line. When I learned IFR flying, it was on a traditional 6-pack with a mechanical CDI, and I've been loving the additional situational awareness of having the guidance right on my AV30s. Whether you're an experienced instrument pilot or an instrument student, I think you're going to like what we've done. In this video, I'm going to walk through the AV30 modes and interfaces when using the AV-HSI. But first, let me give you a quick overview of the product. The AV-HSI is small and packs a lot of capability. In short, it converts the ARINC 429 interface found on IFR navigators into an interface usable by the AV30. It interfaces with a GPS source and a VHF source, whether they're from the same unit, like a GNS 430, or from a standalone GPS and a standalone Navcom. It also interfaces with up to 4 AV30, serving navigation data to all 4 and acting as an information hub that synchronizes data between the AV30s. The installation manual and pilot guide for experimental aircraft are available under the support tab at uavionics.com. This video doesn't replace those manuals, so please take some time to read them. Here's a picture from one of our flight tests in a company plane with 4 AV30s installed. One is out of view. It was set up as a dedicated traffic display showing nearby ADS-B traffic from our sky sensor. The other 3 are set up showing the other 3 AV30 modes: attitude indicator, directional gyro, and course deviation indicator. With the AV-HSI, all 3 modes will show both lateral and vertical guidance. The CDI mode is new with the AV-HSI and AV30 software version 2.6.0. Let's walk through the changes to the AI and DG modes, and then we'll dig into the CDI mode after. Here's the attitude indicator mode when running with the AV-HSI. For current AV30 users, it'll look familiar. The lateral and vertical deviation bars are new. Like other overlays, they can be enabled or disabled. Additionally, there are new nav mode and OBS overlays that can be added. The deviation indicators are magenta for GPS sources and green for VHF nav sources. In these pictures, the AV30 on the left is flying an LPV approach, the AV30 on the right is flying an ILS approach. To declutter the screen, the vertical deviation bar will only show up when glide slope data is available from your navigator. For ILS approaches, this happens when your radio is tuned to an ILS frequency and is receiving a signal. For GPS approaches, this varies by the approach type. Check your GPS manual for details. You'll notice the lateral deviation indicator is an arrowhead shape. The arrow pointing up is a 2 indication. If we were navigating on a radial from a station, the arrowhead would point downward. As an aside, the graphics are screenshots from the AV30 simulator that's available for free on our website. It requires a Windows PC, but it's worth checking out. Now let's walk through the directional gyro HSI mode. An LPV approach is shown on the left. The right shows tracking VOR radial. The first obvious change is the glide slope indicator. Like the attitude indicator, it shows up when glide slope data is available. A subtle but super useful addition is the bearing pointer for VOR stations. The bearing 2 station was always there for GPS. We've added the VOR one. Again, GPS is magenta, VHF is in green. The current nav mode is displayed in the background. The nav mode overlay is also available and can be put in any of the 6 overlay spots. Without the AV-HSI, the course deviation bar has a set scale of 1 nautical mile per dot, and the HSI mode is limited to VFR only. When flying with the AV-HSI, the scale varies by the navigation or approach mode, and this guidance can be used for IFR flying. Over on the right side, the first thing you'll notice is a graphical to/from indicator. The arrow points towards the tail of the deviation bar when flying from a station, and toward the head of the deviation bar when flying to a station. The same graphical to/from indicator will be present when flying a radial off a GPS point. The VOR indicator has a scale of 5 degrees per dot. Both of these images show heading tied to the DG. The heading can also be tied to GPS track. When flying vectors from ATC, you'll want to use DG, but once on an approach, I've come to prefer GPS track because it takes away the guesswork of compensating for wind. The DG arc mode has also gotten an overhaul. We had a lot of fun developing this, and it's something not often found in instruments of this size or price point. The arc mode in the original AV30 would only display the current navigation waypoint. Our last software release, version 2.4.1, expanded to display a full flight plan. The AV-HSI in version 2.6.0 takes this further by adding curved waypoint segments, including holding patterns and DME arcs. Just like the attitude indicator, lateral and vertical guidance overlays are available. It's important to note that the moving map itself should be used for situational awareness only. It doesn't zoom in enough to be used as the sole navigation resource for approaches and is labeled as VFR only for that reason. The lateral and vertical deviation overlays, however, provide IFR approach guidance. Again, bearing pointers for both GPS and VOR are available on screen. In this particular image, they are both off-screen to the left and right, respectively, as denoted by the pointers. The last mode to show you is the course deviation indicator. It is completely new with the AV-HSI and mimics the mechanical indicator I learned on, but with some really nice digital additions. As with the other modes, it'll show lateral and vertical guidance for both GPS and VHF navigators. The outside compass ring is tied to the OBS setting, which I'll show you shortly. For GPS and ILS approaches, the OBS doesn't matter. It comes into play when tracking a VOR or a radial from a GPS fix. As with all the other modes, there are several user configurable spaces available for data overlays. They can be turned off entirely to declutter if you prefer. We've made 2 CDI pages available. I typically have one set up for the data I want for approaches and one set up with the data I want en route. As with the AI, DG, and MFD, the last page brings up a reversionary attitude indicator. Bearing pointers to GPS and VORs are available. The navigation mode is enunciated in the background. Now that we've looked at the operating modes, let me show you the user interface. Knowing the workload of single pilot IFR, we tried to keep things simple and be consistent with our current AV30 workflows. There are 2 additional controls in the push step menu, Navigation Source Select and OBS. Let me give you a quick demo of how those work. AV30 users will be familiar with pushing the center button to cycle through items in the push step menu. Setting the navigation source is no different. Click the center button until you see Source Select. Rotate the knob to select either GPS or VLOC. If you're using an all-in-one GPS navcom like this Avidyne IFD 540, switching the source on the navigator will also switch source on the AV30s. The next menu option sets the omni-bearing selector. There's an auto mode that will automatically set the OBS from the GPS flight plan, or the knob can be rotated to dial in a specific course. A long hold of the center button will automatically set the OBS to the current bearing to station. This video is showing VOR guidance, but GPS works the same way. You might have just noticed one new feature with the AV-HSI. The AV-HSI networks up to 4 AV30s together, so when you change a parameter on one, it gets changed on the others as well. Currently, the AV-HSI will synchronize heading bug, nav source, OBS, set altitude, set vertical speed, autopilot mode, baro, and any manual DG adjustments you make. Additionally, the AV-HSI shares data from an outside air temperature probe, so if one AV30 has an OAT probe, all the AV30s will get the data. This synchronization is a good time saver, though synchronization of each parameter can be turned off individually if you prefer the AV30s to operate more independently. Lastly, the AV-HSI continuously compares the attitude solution of each attached AV30. If any of the connected AV30s disagree on pitch or roll, an alert will pop up. Think of it as an aid to your normal instrument cross-scan, only this cross-scan happens automatically several times a second. We haven't covered the new autopilot integrations that use the AV-HSI, but let's leave the AV30 autopilot interfaces to another video. I hope you've enjoyed this overview of the AV-HSI. If you have any questions, please reach out to us. There are a variety of ways to get in touch with our support team. uavionics.com/support is a good place to start. Until next time, wishing you safe and happy flying wherever your journey takes you.